Hey guys, what's going on? My mic stand is being stupid. I'm back. I didn't forget. I was busy. And my Wi-Fi on my computer was being really dumb. But I'm here now. So, it says there's one person. There's probably not. But that's okay. I'm probably going to get started. I made a list a long time ago that I'm glad I made regarding specific topics that we should talk about in regards to the staple virtual machine. And we get that. Can I? Oh my gosh. So we're going to go over those topics probably like now. Placeholder comment. Thank you. Hello. I don't remember how to pronounce your name. Dumminch. I like that. Thank you for showing up immediately. Appreciate that. I don't feel so alone anymore. Okay. So let's just get going. Something I realized last time we ended with an endian problem where I think we were doing little endian instead of big endian on accident. And I had claimed previously that the halt should work by just popping an 8-bit number off the stack. So just 1 byte instead of... I probably have this turned up too loud. I'm going to turn that down just a little bit. 1 byte instead of 4. But it wasn't working, and then I had to do this. I love you too. I don't know how to send the thing from here. I can't, unfortunately. But now we should be able to just change this to just an 8-bit pop, and it should work. I'm gonna have to. It's been a while since I've been in the code base, because I don't touch this unless I'm streaming. So yeah. So let's just see. I forget. I probably don't even have a help page, do I? It's probably just this. What were we testing before? Let's see. Okay, cool. So that does work. So that's fine. So that works exactly as we would expect it to. And we'll leave it that way just because any return code that we have, it can only go up to 255, I believe. So there's no point in popping 4 bytes off of the stack if it's going to just chop off the 3 anyways. So I'll just leave it like that. So that takes care of that problem. So I've got my notes over here in a different window. Okay, that's good. Care about empty lines and tabs, except I did say I loved you. Who just... I think someone just arrived at my home. Oh, okay. So, I just want to make sure that that's probably it. So in our parser, I'm going to go and clean all this. In our parser, we have some to-dos here. Yes. We need to care about empty lines and about tabs. So let me think about that. Again, I haven't like been in the code base for a little bit, so it's gonna take me a second. I guess if and or no, that's not right. Wait, is it? Okay, so if we didn't increment this, that means we haven't set anything here. Ooh. Oh, that doesn't matter. Okay. So if our lexical buffer is empty, that means that we've hit another special character. And I don't think... Yeah, I think it'll break. Yeah, it doesn't work. Because then the lexical buffer gets set to just nothing, and then it's gonna... Wait, I don't know what I'm talking about. What does this do? I want to see what this does. Okay, so there's the problem. We should have lines, shouldn't we, on the syntax errors? Let's put that like here. Because we're keeping track of the line, we may as well. Yeah, okay. So on line 4, which is this one, it says that there is no such instruction and then just nothing, which is here. Okay. So I guess because this is just checking two things right now, it's just saying is there a hash or is there not a hash symbol? And if there is not a hash symbol at the beginning, then it just assumes that it's an instruction, and it's definitely not. So up here, I guess we can just skip, right? We can just skip it. So if we went nowhere and we have a special character, and that special character is a new line. Actually, I think we can check in just a second. It should also work with a tab character, because anything that's like a tab, we can just skip that. But first, let's just care about empty lines. We can just, I think we can just do this. And go to another line and then just continue. That should solve that problem. I think that solved the problem. Let me... Oh. Duh. Okay, so that's working. Okay, so that solves that problem. That means we can have empty lines and it won't give us an error any longer. So, okay, got that done. Now we have to care about tabs, because I don't think tabs are going to work. We're not looking at tabs right now. So if we have a tab, we have to add that in here. Don't we? Is that all? It might be all. I can do that just to see. staple compile first STVM. Okay, no, so it has an error. Can we? Because it'll break on that every time. Let's just add that. Oh. Okay, so I'm gonna a little bit nest these. Right, and unfortunately we have to check that again. We can one line that. And that should fix the problem. Yeah, there we go. Okay. Wow, we are certainly killing it tonight. Empty lines and tabs. So this just kind of takes care of it before we even get to the part that's like trying to take apart what the actual Lex buffer has. Because I mean really because there's nothing in it. And we even set that here. It's literally just nothing. It's nothing that we can do. There's nothing we can do with it. So yeah, this just kind of takes care. I mean, you could have another tab, right? And then it would. Well, the tab would actually just cut it off because I could theoretically tab here, even though that looks absolutely disgusting. And that should still work. Yeah, so, okay. So we took care of sort of the white space issue. That's taken care of. So when we end up adding labels, right? So let's just do a whole new thing here. Let's just... we have a little bit before we get to this point, but if we have something like square and then let's have a proof of concept here. Let's have square. Right, so we can start up here. We're gonna eventually have registers, so I gotta think about something like that. Probably percents will be the way to go. 5. Let's say that we call square. I think in the past I've done like @ symbols to mean like a label, so I'll probably do that. Some sort of identifier, or we could do that. That's probably easier. It can just be some sort of identifier. At the end of the day, this doesn't matter like as much as the higher level language that we'll be making. So I guess like syntactically, not everything matters. It matters as far as debugging. But at the end of the day, this is just more of an intermediate that is just gonna compile the bytecode. And the compiler doesn't care what we put in front of things, just cares that it knows. So we can have this, and then we'll tab over, right? Because that would kind of indicate that we're a part of this. And so like syntactically, that's something that we care about. We can have that, right? And then halt. So something like that. I guess that's like calls, which we won't have for a little bit because we have to figure out what we want to do with the call stack. I'm going to get rid of that because we don't need that. I think that's how you spell delimiter. Goodness. Okay, so that's done. That didn't take very long at all. I was going to discuss generics, but I'm going to do that at a later time because I don't remember what I was thinking about that. something about how C11 has almost a way to do generics and how maybe that would be useful, but it's at this point it's not, it doesn't matter all that much. Okay, something else that I wanted to do. This might be a shorter stream today. I need to get back in the game a little bit. We can do that later too, because I want to get on registers pretty quickly. The registers are useful. I wanted to do a little bit of cleanup as well. Something, I need to move the bitwise functions. So, because we have this code repeated like 1,000 times where we're shifting things around, and we don't necessarily need to do that. That can be, because I think we have a util here. Yeah, where we have the buffers that we can read and write to that are actual real C buffers. And so I kind of feel like we should just have these and then just not re-implement, but call these whenever we need to use them. And so I think that's what I'm going to do. I just have to, excuse me, I'm just actually going to just look. How many times do we do this? Yeah, because we don't... I guess we kind of need it to be different here, because we have a specific pop function that actually does more than just read from a buffer. It actually changes other values, and so we need that to be the same. What about this? Do we have that anywhere? Okay, these are all the other ones, I think. And like maybe this, we don't necessarily need to have this because we're just writing, just doing whatever this is right here. Although, because it's calling a thing. Yeah, maybe we'll just leave it. Maybe we'll just leave it. Maybe that's the best thing to do. Just to not worry about it and just leave what we have. So I'll come back to that, I suppose, because there's no need to kind of reinvent. We don't need to like redo everything. We kind of already have it. So, okay. So let's move on to, let's get some more instructions. Let's get some more math instructions in here, because that would be very nice. So let's start by coming in here and adding a sub and a mul. I don't want to do division yet because we have to carry about. We need registers for that. We actually need registers for that, because we need to place the remainder in something, because these are all integers. It's not going to have clean floating point math, which we will have at a certain point because we have to. So do that first. I don't think there's anything in here that's particularly useful. So in the compiler, or no, in the parser, we need to come in here and add it. Yeah. Turn sub. So this is now recognized as an actual instruction in this whole mess of a parser that we have. And then the compiler cares about it a little bit, but first the bytecode thing that we have cares about it. Let's have a sub stack. We'll change all of these at some point. We'll actually need to lay out like a spec, like we need to go through and say, all right, what kind of instructions do we want? Kind of name them, categorize them, move them around a little bit, and then we can decide which constant value they should have. We need to do that kind of early on. But it has to be spec'd at some point, and it has to be backwards compatible to a certain degree. At a certain point, we'll have to say, okay, now this is exactly what it's going to be, and we have to leave these here for the rest of forever, because we need backwards compatibility on different runtimes. or we need new runtimes to be able to run old compiled bytecode. So we can only add things, we can't change them. So that's why it's important to set that up sort of in the beginning. So we'll have a substack. And did I add the mul? Yeah, so we got to do that as well. And multiply on the stack. And then here we take care of actually compiling it all. And the reason we can just do this without checking other things is because these are the only ones that we have. Once we have registers and things like that, then we'll need to come in here and kind of be like, yeah, what's the next one? We need some context for this. What are the arguments here so that we can compile it correctly? Multiply, byte buffer, write 8, C bytecode, mul stack. Break that. And this should compile now. We'll have to actually, let's do math. And we have to also, I don't know if I wrote this down, but we have to also consider a disassembler. Do I have that in here? I don't. We need to very soon create some sort of disassembler that will take apart the things that we build so that we can sort of verify that everything's working the way that we want it to without having to come in and kind of decode this ourselves. Because we can, it's very small right now. We can do that when it's small, but when we start to write bigger programs, trust me, we're going to want one. And we'll need some way of saving symbols as well. We'll need to save debug symbols so that we can see where labels are and we can see where variables are being used. Things of that nature. Because that's also very helpful. That's also very important. You can catch a lot of bugs that way. I guess here we'll just, I don't remember. We don't even have a move instruction, do we? So let's push 12 and 8. So what do we want? We want subtraction. The order matters, and so we gotta kind of figure out what we want to do. So let's just say that it's 12 minus 8. So whatever gets popped off of the stack first is going to be how much the next thing gets subtracted by. I think it might be a good way to do it. We can switch that up later. If man, I don't even remember his name. Now I'm sad. If Reese comes in here and decides that we need to do something better, then we'll do that. So we'll test the subtraction first, and then we'll test the multiplication, and that'll be like 96 or something. Something like that. But first, we have to make sure that it compiles. So let's do that. It appears that it did compile, so let's do the thing. Stable bytecode. Let's take a look here. Let's see what we got. We've got our push. We pushed 12. We've got our push. We pushed 8. We've got our 3, which I believe is what we said for subtraction. That's good. And then we've got our halt instruction. So that's looking pretty good. That looks like we did that correctly. So let's go over to our runtime and actually implement the subtraction My dog is having a conniption. So this should be B minus A. Unless we want to... I mean, I guess because things are supposed to be pushed reverse, we should probably... Oh, jeez. And there he goes. He's having a great time. So let's move that. So it'll be 12 minus 8, so it'll be reversed. But because stacks kind of have the nature of being reverse, good lord. Then we'll just do it like that. That is some good water. Let's move these around so we're the chain that we want. Okay, that's looking good. That's looking good. That should do what we want it to do. That should give us 4. And we got 252, which is exactly 4. It's 256 minus 4, so we did something wrong, is what that means. It means that did we get the endianness wrong again? Is that even possible? Or no, what is it? Because we're reading, or no, wait. It's pushing the thing that we found. Okay, so it pushes them like that. So when we pop it, it should be, the D should be the last one, yeah. Okay, so then I don't understand what happened there. I mean, I guess for now, you can do that. Nope, come on. Oh, for crying out loud. That and that. There we go. Okay, well that's 4. That concerns me. I'm going to I'm gonna come in here and just check. $29. I don't know the GDB commands. Runtime.c. No, did it not find it? What? Did I said specifically tell it to go here? Be stable. Oh, does it just break? Okay, I'm dumb. I'm used to LLDB because I was on a Mac and GDB was broken on Mac. So I'm not used to this syntax. Thank you, sir. Thank you for or ma'am. Thank you. Program kids. And then run out. Oh, but it's not even, so it doesn't even matter. I didn't. Where's my, oh, I cleaned it. Okay, now GB STBC. Yeah, that must be what it is. I think it must be BR. I'm off my game. I'm off my game today. I need the actual thing and not the thing that we've made. We need the staple and not the bytecode. Okay. Maybe we can actually get around to debugging this thing. There we go. Run out.stbc. There we go. Okay, so what is that? That's 12. That's 8. So A minus B should be it, right? That should be it. I don't know why it's not working. Can I come in here? What is my data? I mean, obviously it's huge right now, so I'm gonna quit and see why it's not working here. Yeah, but they had to make assembly out of something too, right? Someone had to, or maybe, I don't actually know the history, but theoretically, somebody had to go and program assembly with just straight up machine code, which is crazy. All right. So let's try this again and let's see why it's being weird. So if we come here, we can see what A is, which is 12. That's exactly what we want. We can see what B is, and that is 8. That's exactly what we want. However, A minus B is 4. Can I do that? Yeah, that's 4. So then why is it stupid? Yeah, there we go. Okay. So first it's going to push whatever garbage information it's got there, and then that, and then that, and then that. What is my stack called? Just stack. What's at the stack pointer right now? Oh, no, it's runtime. Oh, no symbol runtime in current context. What is it called? It's just R. 0, 0, 0. Or is it plus because it goes down? Yeah, so I don't understand why it's breaking. Kind of confused. We should come to the halt, right? Okay, so that's 4. Right? And pop 8 just took what we looked at. Oh my gosh. So that's 4. Right, so then now we're in the main. I am on Ubuntu, yes. Right, and runtime exit is 4. Just continue. Yeah, exit with code 4. Am I just dumb? Did I just do all that for nothing? Did I just not have it compiled correctly? And I just did that? Yeah, I just did that for nothing. Okay, cool. All right, sorry about the last, sorry for wasting the last 10 minutes of your life. That was probably the dumbest thing ever. Okay, so we already have the multiply, so let's just substitute that in there. No, just mul. And let's add that. This time we won't have problems because like addition, it doesn't matter what order you multiply in. I don't remember if that's called transitive. I don't remember what anything is from math. Oh, that's weird. A times b commutative. That makes sense. Yeah, commutative. Okay. That makes a lot of sense. So now we should be able to compile our math VM code, which it does, and we can take a look very briefly. It's going to look exactly the same, except we have this 4 here now because we've defined that our multiply operation or opcode is 4. So that will do what the subtraction did. And if we run out.stbc, we should get 96, and we do. Absolutely amazing. Can't believe I wasted time looking for a problem that had already been solved. So, okay, so that wasn't even on my list of things to do, but that's okay. We could do registers. Let's start with registers, I think. We should start on some registers for a little bit. I think that'll be fun. It might take a little bit, but we can do it. I believe in us. So let's have, or I guess I'm going to go ahead and commit. Oh man. I'll do that. Okay, so we've got 7. There we are. Added, or no. What do? We care about new lines and empty lines. Sorry, empty lines and tabs. Stack operations for sub and mul. I think that's about all we did probably. So let's go ahead and throw that up there. There we go. I need to link to the GitHub somewhere for this because if y'all want to look at the source, it should be allowed when I'm not streaming. You shouldn't have to go back and scrub through my videos that are on YouTube. Okay, what did I want to do? I wanted to do registers. So let's do that. Oh, that's not what I wanted at all. I wanted to add a new file. Ergs. Okay, what can we do that's simple? So we're gonna have to do a couple of things. We're gonna have to have the move instruction. We're going to say that the percent is how registers are handled or referenced, I guess. Not reference is already a word. That's how we know it's a register. And I want to be able to move information into it. So right now I can move a number. So right now we need a move instruction. Okay, first we need to be able to understand what registers are. We have to kind of define those a little bit. How about plan features as well? As far as what? Like in the commit, did you want plan features in the commit message? We need also, so we need to understand what that is just in code. We need to be able to compile something like that. We need to be able to have a move instruction. We need to add another add instruction that adds to that. And then let's do that as well. Let's have a push for registers. We should be able to do that. And then because of the way our halt is working, it'll just pop the last thing. That looks good. So there's a lot to do. Probably won't get it all done tonight because I didn't want to stream for a super long time tonight, but we'll get working on this. So we have another token type now. We have registers, which we will parse by checking if there's a percent. And because of C strings, I think we have to have 2. Maybe not. Maybe we don't. Maybe we do. Maybe we don't. I'm going to do just percent in C string. Is that only needed for this? Okay, cool. So that's fine. We don't need to do anything about that. What now? We should return something. Got token inst. Let's have token register. We'll just have the 1 right now. And we can make this a type. We can type def this. I guess that's in the parser. We'll need a parser get register as well. So let's define that very briefly. Token register, parser get register. Or just get reg. It's probably okay. Do that down here. And we don't have to do the crazy thing that we did up here for the number. We don't have to get rid of this % because we don't just need the EAX. We just need to, we can put that here. We can include it because there's like the value. This isn't very special on its own. Let's see, return EAX. Otherwise, return, what do we do? Token register -1. Is that what we did? So we can do token register parser get register. Or I guess it's an int because that's how we set up our token structure, right? These are just ints. Oh. We need the same thing here. This means that we're good. Otherwise, there's a problem. So we'll just do what we did before. Syntax. Come on. Error. No such register. Parser syntax error. And here we can create our token. Remember that this is just up here. Register and reg. Is that all good? Why are you complaining? Too few arguments? Line. There we go. And that's registers right there. So that we'll have to add more because we don't want just one register. It's kind of stupid. We'll add more. A lot of this is just we need to add more. We need to add more instructions. We need to add more registers. But that is pretty good. Let's have. We need a register. Yes, I do. Yes, I do. Thank you for that catch. I do mean to pass Alexa's second argument. So we need to have register EAX. Yeah, that's gonna be obnoxious later, but we'll just do this right here. That'll be good enough for now. So, oh, also we need to add the move instruction. need to have a move register const. I guess it doesn't matter. Like I said, we'll be changing a lot of this anyways, so we can just kind of do whatever we want here. Jeez. Cool. So let's do move register const. That's not correct. We need just the move. So we need move register const here. So if the following operand is a register followed by another operand that is a number, then we will write byte buffer. We will write the move. This is where we want the red const right here. We will do that. Oh, that's sad. I need to change that. Tokens, right? Nope, bytecode. Got it. We will also need to write the register, which really is just, I mean, we could come over here even and set that to like 1. We could just do that for every one of them because there's not going to be a whole lot of those, so it doesn't really hurt us too much. Token list get c tokens I plus 1 data, and then we will write our 32-bit number, which we can just kind of grab that. Otherwise, we have bad move instruction. These are really crappy. These are really crappy debugging messages. The nice thing is that we can do this because we're keeping track of the lines. Do I have the current token line? Yeah. So I can do this now. Just so it's more specific and we're not having to look and find it, because it's not specific without a line number really. If we have more than one of these, then it can become frustrating. So that should work there. We need to add another add, right? Yeah, geez. I'm not going to be able to get all this done. Yeah, we are coming up on the hour, and I will probably stop it around here just for now. We'll have part 3.5 maybe sometime later this week, because my back is beginning to hurt. I've been sitting down all day. And we've still got quite a bit to go. So I'm going to go ahead and leave it here. Thank you to everyone that tuned in. Super appreciate you guys.